Here is one of the most important topic, that is divergence of a vector and solenoidal vector. Let's see what is divergence and solenoidal vectors. So let f bar is equals to f1 I bar plus f2 j bar plus f3 k bar is a vector differential point function. Then the divergence of f bar is denoted by div f bar is equals to I bar dou f bar by dou x plus j bar dou f bar by dou y plus k bar dou f bar by dou z. So here we are taking one vector, that is f bar, and this is a vector differential point function. We are calling it as vector because it consists of I bar and j bar and the k bar vectors. So when we to find out the divergence of these f bar vector, so we have this formula, that is I bar dou f bar by dou x plus j bar dou f bar by dou y plus k bar dou f bar by dou z. So from this we are differentiating f bar function with respect to x, y and z. Now this can be written as I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z into the vector f bar. So that equals to I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z into f bar vector is f1 I bar plus f2 j bar plus f3 k bar. So div f bar is equals to, now we know the dot product of I bar is, dot product of I bar and I bar is 1, and dot product of I bar with j bar and k bar becomes 0. So here I bar coefficient is d by dx, sorry dou by dou x, and here I bar coefficient is f1. So it both get multiplied. Then we get dou f1 by dou x, and similarly with j bar dou by dou y with f2 j bar. So we get dou f2 by dou y plus dou f3 by dou z. So this is the div f bar, and this can also be written as the del dot f bar. The both means the same. So to find out the divergence of a vector, the vector is given, then we can use the formula dou f1 by dou x plus dou f2 by dou y plus dou f3 by dou z, where f1, f2, f3 are the coefficients of the vector, coefficients of the I bar vector, j bar vector and the k bar vector in the f bar. And then here we shall see the solenoidal vector. A vector f bar is said to be solenoidal vector if del dot f bar is equals to 0 or div f bar is equal to 0. So when we find out the div f bar, if we get the value of div f bar as 0, then we call it as the solenoidal vector. That is del dot f bar is equals to 0 or div f bar is equals to 0. So here we have the two note points. Gradient of a scalar point function is a vector point function, and the divergence of a vector point function is always a scalar point function. So here vector point function nothing but it consists of I bar, j bar and k bar vectors. So scalar point function we have seen, that is pi of x comma y comma z. So this is some function, it consists of only x, y and z variables. It doesn't consist of I, j, k vectors. Whereas vector point function, it consists of I, j, k vectors. So when we find out the gradient of this, we get the vector point function. And when we find out the divergence of the vector point function, we get the scalar point function. So for more clear to understand this, I'll explain you one problem. Here we shall go with the few important problems on the divergence and solenoidal vector. So first question we have, find divergence of the vector f bar, that is div f bar, if f bar is xy square I bar plus 2x square yz j bar minus 3yz square k bar at the point 1 comma minus 1 comma 1. So we know that f bar is equals to f1 I bar plus f2 j bar plus f3 k bar. The given equation is f bar is equals to xy square I bar plus 2x square yz j bar minus 3yz square k bar. So this is a f bar vector, and when we compare these two equations, f1 coefficient, in the place of f1 we have the xy square, and in the place of f2 2x square yz, and in the place of f3 we have minus 3yz square. So f1 is xy square, f2 is 2x square yz and f3 is minus 3yz square. So we got the f1, f2, f3 values. So to find out the divergence of the vector f bar, we have the formula. That is dou f1 by dou x plus dou f2 by dou y plus dou f3 by dou z, which gives the divergence of the vector f bar. So now substitute the values of f1, f2, f3 in this formula. We get dou by dou x of xy square plus dou by dou y of 2x square yz plus dou by dou z of minus 3yz square. So differentiate here. We are differentiating with respect to x. So y square is constant and x differentiation is 1. Plus here we are differentiating with respect to y. So 2x square z is constant and y differentiation is 1. Minus 3y is constant and z square differentiation with respect to z is 2z. So we get it as y square plus 2x square z, 3y into 2z, that is 6yz. So this is the divergence of the vector f bar. Now we have seen the two important points of in the solenoidal vector, that is the vector divergence of the vector point function is always scalar point function. So here we got the scalar point function. It is only the function consisting of x, y, z variables. It doesn't consist of I bar and j bar and k bar vectors. So when we find out the divergence of the vector point function, we get the scalar point function. And then now we have to find out the divergence of the vector f bar at the point 1 comma minus 1 comma 1. So now substitute the values here. In the place of x, you have to substitute 1 and y is equals to minus 1 and z as 1. So substitute here, we get minus 1 whole square plus 2 of 1 whole square into 1 minus 6 of minus 1 into 1. That is 1 plus 2 plus 6, that equals to 9. So therefore the divergence of the vector f bar is 9. And the second question, find div r bar where r bar vector is given as xi bar plus yj bar plus zk bar. So given that r bar is xi bar plus yj bar plus zk bar, so in terms of r, if we write, the vector will be r bar is equals to r1i bar plus r2j bar plus r3k bar. Now when we compare the equations here, two equations, we get r1 value as x and r2 is equals to y, r3 is equals to z. So div r bar, when we find out the divergence of the r bar, we get div r bar is equals to dou r1 by dou x plus dou r2 by dou y plus dou r3 by dou z. Now substitute the values of r1, r2 and r3 and we have to differentiate it. So here div r bar is equals to dou by dou x of x plus dou by dou y of y plus dou by dou z of z, that equals to 1 plus 1 plus 1 and div r bar we get it as 3. Then here we shall go with the third question, that is find div r bar where f bar is equals to gradient of x cube plus y cube plus z cube minus 3 into x y z. This is a very most important question which can be asked for the 5 marks. So here they given that the f bar vector has the gradient of one scalar point function. So this is a scalar point function because it doesn't consist of I, j, k vectors and it consists of only x, y, z variables. So here f bar is equals to grade of x cube plus y cube plus z cube minus 3xyz. So we are assuming this as a pi which is a scalar point function. So now f bar is equals to grade pi. So where pi is, we assume it as x cube plus y cube plus z cube minus 3 into xyz. So when we have to find out the gradient of the pi, then we get the f bar vector. So gradient of pi, that equals to del pi is I bar dou pi by dou x plus j bar dou pi by dou y plus k bar dou pi by dou z. So del pi is equals to I bar dou by dou x of x cube plus y cube plus z cube minus 3 into xyz plus j bar dou by dou y of x cube plus y cube plus z cube minus 3 into xyz plus k bar dou by dou z of x cube plus y cube plus z cube minus 3 into xyz. So now we have to differentiate the pi with respect to x, y and z. So del pi is equals to I bar x cube differentiation with respect to x is 3x squared and y cube plus z cube differentiation becomes 0 and here minus 3yz is constant, x differentiation is 1. So we get 3x square minus 3yz plus j bar into y cube differentiation is 3y square and x cube plus z cube differentiation becomes 0, and here minus 3 xz is constant. So plus k bar of 3z square minus 3xy. So this is the del pi, that is f bar is equals to grade pi is equals to 3x square minus 3yz I bar plus 3y square minus 3xz j bar plus 3z square minus 3 into xy of k bar. So this is the f bar, which is the gradient of pi. So here we have seen the two important points in the solenoidal vector, that is the gradient of the scalar point function, which gives the vector point function. So when we are find out in the gradient of a scalar point function, we get the vector point function. So this is a vector because it consists of I, j, k vectors. Now here this f bar is grade pi. So when we compare with the formula, that is f bar is equals to f1 I bar plus f2 j bar plus f3 k bar. f1 is 3x square minus 3yz, which is I bar coefficient, and f2 is the j bar coefficient, that is 3y square minus 3xz, and f3 is 3z square minus 3 into xy, which is the k bar coefficient. So we got the f1, f2, f3 values. Now we can find out the divergence of the f bar. So this is not r bar, this is f bar. Then divergence of f bar is equals to dou f1 by dou x plus dou f2 by dou y plus dou f3 by dou z. So div f bar is equals to dou by dou x of f1 is 3x square minus 3yz plus dou by dou y of f2 is 3y square minus 3xz plus dou by dou z of f3, that is 3z square minus 3 into xy. Now we have to differentiate here. So div f bar is equals to 3x square differentiation with respect to x is 3 into 2x. That is x square differentiation is 2x plus here the differentiation becomes 0, and plus 3y square differentiation, 3 is constant and y square differentiation is 2y, and minus 3x z differentiation becomes 0 plus 3 into 2z minus 0. So overall we get it as 6x plus 6y plus 6z. So this is the div f bar is equals to 6x plus 6y plus 6z. So here you can see when we got the f bar vector, the second point in the solenoidal vector, that is divergence of the vector point function, which gives the scalar point function. So in this one problem we can explain those 2 points. Let's see one more question. Here is fourth question, that is if f bar is equals to x plus 3y of I bar plus y minus 2z of j bar plus x plus pz of k bar is the solenoidal, then we have to find out the value of p. So given that the f bar vector is solenoidal vector, first we have to find out the divergence of the f bar. So given f bar is equals to x plus 3y of I bar plus y minus 2z of j bar plus x plus pz of k bar. So we have the equation f bar is equals to f1 I bar plus f2 j bar plus f3 k bar. So when we compare this equation with the question, f1 is the I bar coefficient, that is x plus 3y, and f2 is the j bar coefficient, that is y minus 2z, and f3 is the coefficient of the k bar, that is x plus pz. Now we know that the divergence of the f bar is we have the formula, that is equals to dou f1 by dou x plus dou f2 by dou y plus dou f3 by dou z. So substitute the values of f1, f2 and f3 in this equation. So we get div f bar is equals to dou by dou x of f1 is x plus 3y plus dou by dou y of f2 is y minus 2z plus dou by dou z of f3 value is x plus pz. So div f bar is equals to, here differentiation of x with respect to x is 1 and 3y differentiation becomes 0 plus y differentiation with respect to y is 1 minus 2z differentiation is 0 plus x differentiation with respect to z is 0 plus here p is a constant and z differentiation with respect to z is 1. So we get it as p. So that is div f bar is equals to 1 plus p. So div f bar is 2 plus p. This is the div f bar. Now we have to find out the value of p. So given that the f bar vector is solenoidal vector, So we know that if it is a solenoidal vector, divergence of the f bar is 0. So given f bar is solenoidal vector, that is divergence of f bar is 0. But here divergence of f bar we got it as 2 plus p. So 2 plus p is equals to 0. So send this 2 to the right hand side, we get p is equals to minus 2. So this is the value of p. Now here is the most important question on the divergence of a vector. So this one question can be asked in 3 ways. So first is find divergence div f bar, where f bar is r power n dot r bar. Find n if it's solenoidal. So we had to find out the divergence of the f bar vector, and f bar vector is given as r power n dot r bar. Is a dot product of this. So whenever the r is given, we have to take the vector as xi bar plus yj bar plus zk bar. That is the r bar vector. Even if it is mentioned or if it is not mentioned in the question, we have to take the r bar vector as xi bar plus yj bar plus zk bar. So we had to find out the divergence of the f bar, and here we had to find out the value of n when it is a solenoidal vector. And another way of asking the question is prove that r power n dot r bar is a solenoidal if n is equals to minus 3. Or prove that divergence of r power n dot r bar is equals to n plus 3 of r power n, and hence show that r bar by r cube is solenoidal vector. So r bar by r cube nothing but r bar dot r power minus 3. We have to prove that it is a solenoidal. Let's see the solution for this question. This is the answer for the first question. Let r bar, we have to assume it as xi bar plus yj bar plus zk bar. So r is nothing but the modulus of r bar. So mod r bar is equals to root of x square plus y square plus z square. Now when we square on the both sides, we get r square is equals to x square plus y square plus z square. Now we have to differentiate this equation with respect to x, y and z. So when we differentiate with respect to x, we get 2r dou r by dou x. Since we are differentiating with respect to x and r is another variable, so we get dou r by dou x. And on the right hand side, y square plus z square differentiation becomes 0, and x square differentiation with respect to x is 2x. So on the both sides 2 gets cancelled and send r to the left hand side. So you get dou r by dou x is equals to x by r. Similarly for the, we have to differentiate this equation with respect to y. We get 2r dou r by dou y is equals to 2y, and dou r by dou y is equals to y by r. Differentiating with respect to z, we get dou r by dou z is equals to z by r. Now the given equation is f bar is equals to r power n dot r bar. So that is nothing but r power n into r bar vector is xi bar plus yj bar plus zk bar. Now multiply this inside. So we get f bar is equals to x into r power n I bar plus y into r power n j bar plus z into r power n k bar. F bar vector. Now when we compare this f bar vector with this equation, that is f bar is equals to f1 I bar plus f2 j bar plus f3 k bar, where f1, f2, f3 are the I bar, j bar, k bar coefficients. Similarly, when we compare here, we get f1 is equals to x into r power n, and f2 is y into r power n, and f3 is z into r power n. Now we got the f1, f2, f3 values. So we can find out the divergence of the vector f bar. So that is dou f1 by dou x plus dou f2 by dou y plus dou f3 by dou z. Now substitute the values of f1, f2, f3 here. So we get dou by dou x of x into r power n plus dou by dou y of y into r power n plus dou by dou z into r power n. Now we have to differentiate this. So here we have to use the UV method, because we have the x into r power n, where x is a u and the r power n is a v. So when we use here, we get x into n into r power n minus 1 dou r by dou x. R power n differentiation is n into r power n minus 1, and since we are differentiating with respect to x, we get dou r by dou x plus r power n is constant, and x differentiation, that is dou x by dou x plus y into r power n differentiation with respect to y. We get y into n r power n minus 1 dou r by dou y plus r power n into dou by dou y of y plus z into n into r power n minus 1 dou r by dou z plus r power n into dou by dou z of z. Now we have to solve this, substitute the values of dou r by dou x. So here div f bar is equals to x into n into r power n minus 1 dou r by dou x value we got it as x by r plus r power n into differentiation of x with respect to x is 1 plus y into n r power n minus 1 of dou r by dou y value is y by r plus r power n into 1. And similarly z into n into r power n minus 1 dou r by dou z value is z by r plus r power n into 1. So we get div f bar is equals to, here x into x is x square and n into r power n minus 1. Here 1 by r will be left, and when we send into the numerator we get it as r power minus 1 plus r power n into 1 is r power n. And similarly plus y into y is y square and n into r power n minus 1 and 1 by r can be written as r power minus 1 plus r power n into 1 is r power n. And similarly here we get z square n into r power n minus 1 into r power minus 1 plus r power n. Now div f bar is equals to, here r power n minus 1 r power minus 1, when bases are multiplying and when bases are same, so the numerator the powers get added. So n minus 1 minus 1 we get it as n minus 2. So that is x square n into r power n minus 2 plus y square into n into r power n minus 2 plus z square into n into r power n minus 2, and here r power n plus r power n plus r power n, which gives the 3 into r power n. Now div f bar is equals to, from these three terms we can take n into r power n minus 2 as common. So when we take common, n into r power n minus 1 of x square plus y square plus z square plus 3 into r power n. So div f bar is equals to n into r power n minus 2, and at starting we have seen x square plus y square plus z square can be written as r square. So n into r power n minus 2 into r square plus 3 into r power n. Now div f bar is equals to, here the bases are same and they are multiplying, so the powers will be added. So n minus 2 plus 2 minus 2 plus 2 get cancelled, the remaining is only n. So we get n into r power n plus 3 into r power n. So div f bar is equals to, from this both the terms we can take r power n as common. So r power n of n plus 3. This is the div f bar. Now they asked to find out the value of n if it is a solenoidal vector. So given it is a solenoidal vector, that is, if it is a solenoidal vector, we have the divergence of the vector f bar is 0. So div f bar is equals to 0. But here div f bar we got it as r power n of n plus 3, and that equals to 0. So from this n plus 3 is equals to 0 and n is equals to minus 3. So the value of the n is minus 3. So in this way we can find out the value of n. Here is a solution for the to prove the r bar by r cube is a solenoidal vector. So to prove this, that is nothing but r bar by r cube can be written as r bar dot r power minus 3. So we have to prove that it is a solenoidal vector. It means divergence of the f bar should be equal to 0. So f bar is equals to r bar dot r power minus 3, and f bar is equals to r power minus 3, and r bar can be written as xi bar plus yj bar plus zk bar. Now multiply here. F bar is equals to x into r power minus 3 I bar plus y into r power minus 3 j bar plus z into r power minus 3 k bar. And f1 is x into r power minus 3, f2 is y into r power minus 3, and f3 is z into r power minus 3. So divergence of the f bar vector is dou f1 by dou x plus dou f2 by dou y plus dou f3 by dou z. Substitute the values of f1, f2, f3 in this equation. We get dou by dou x of x into r power minus 3 plus dou by dou y of y into r power minus 3 plus dou by dou z of z into r power minus 3. So this solving of this answer is similarly to the previous one. But there we was having n, and here and there we had to find out the value of n, but it is reverse to this. So we get div f bar is equals to x into n into, that is minus 3 into r power minus 3 minus 1, n into minus 1. So minus 3 minus 1 and dou r by dou x plus r power minus 3 into dou by dou x of x. So similarly y into n into, that is minus 3 x into r into n minus 1, that is minus 3 minus 1 and dou r by dou y plus r power minus 3 into dou by dou y of y. Similarly z of minus 3 into r power minus 3 minus 1 dou r by dou z plus r power minus 3 dou by dou z of z. So div f bar we get it as minus 3 x into r power minus 3 minus 1 is minus 4 and dou r by dou x value is x by r plus r power minus 3, differentiation of x with respect to x is 1. Then we get here minus 3 y into r power minus 4 of dou r by dou y value is y by r plus r power minus 3 into differentiation of y with respect to y is 1. Then similarly for the z, minus 3 z into r power minus 4 dou r by dou z value is z by r plus r power minus 3 into differentiation of z with respect to z is 1. Now we have to simplify this. Div f bar is equals to minus 3 x into x is x square and r power minus 4 and 1 by r can be written as r power minus 3 plus r power minus 3 minus 3 into y square r power minus 4 into r power minus 1 plus r power minus 3 minus 3 into z square r power minus 4 into r power minus 1 plus r power minus 3. So here minus 3 x square r power minus 4 and r power minus 1, it can be written as r power minus 5. Here powers will be added. And similarly here minus 3 y square r power minus 5 and minus 3 z square r power minus 5 plus r power minus 3 r power minus 3 plus r power minus 3, it can be written as 3 into r power minus 3. Now from these three terms we can take minus 3 r power minus 5 as common. So div f bar is equals to minus 3 r power 5, that is minus 3 r power 5. When we take common, remaining will be x square plus y square plus z square plus 3 into r power minus 3. So div f bar is equals to minus 3 into r power minus 5 and x square plus y square plus z square can be written as r square plus 3 into r power minus 3. So div f bar is equals to minus 3 into r power, here powers will be added, so minus 5 plus 2 is minus 3. So minus 3 r power minus 3 plus 3 into r power minus 3. Both the terms gets cancelled and this is equals to 0. So we got div f bar is equals to 0 and hence it is proved that it is a solenoidal vector. So this is a very most important question and practice well.